Hello friends, so this is the video tutorial for today's lead code problem of the day 2211, which is count collisions on a road. The question says there are n cars on an infinitely long road. The cars are numbered from 0 to n minus 1 from left to right, and each car is present at a unique point. Okay, so you are given a zero index string direction of length n. Direction I can be either L, R, or S, denoting whether the ith car is moving towards the left. So L basically means that the car is moving towards left. R means that the car is moving towards the right, and S means that it is static or staying at the same position. Each moving car has the same speed. The number of collisions can be calculated as follow. When two cars moving in opposite direction collide with each other, the number of collision increases by 2. So if one car is moving towards the left, other car is moving towards the right, then both of them will collide, and that would increase the number of collisions by 2. When a moving car collides with a stationary car, the number of collisions increases by 1. So here the only collision is said that if, let's say, our car is moving left towards a stationary car, then only the left car is actually set to have a collision. The stationary car remains stationary. It isn't set to have a collision. So that is why the collisions are only increasing by 1 here. After a collision, the cars involved can no longer move and will stay at the same position where they are collided. Other than that, the cars can not change their state or direction of motion. Return the total number of collisions that will happen on the road. So yeah, this is a medium problem, but I think it's a bit simpler than a medium problem. And yeah, the constraint of the direction dot length is 10 is to r 5 at max, and direction I is L or R or S. Let's just go through this test case. So this test case is that you have R L. One second. Yes. So the first car is going towards right. So here the car is moving towards right. The other car is moving towards left. So if the both of them will meet at some time, number of collisions. Let's see, number of collisions here R and R. So it would be number of collisions equals to 2 because both of them will collide with each other. Then we have a car moving towards right. A car moving towards right. Okay, car moving towards right. Then we have a stationary car. Now this right and stationary car will meet, and if these two will meet, the number of collisions will increase by 1 because stationary car, we said that okay, the collision is only due to R, or only R is colliding, so number of collision plus 1. Now we have S, L, and L and L. Wait, L and L. Both of them will move here. Both of them will collide with S, and yeah. So number of collisions would be 2 plus 1. 1 was for this right, plus 1 for this, plus 1 for this, and this would come up to be 5. Right? This is the answer. Right? And so you can do this two way. One way is that you can like go through from left to right once. So go from 0 to n minus 1 basically. See what is the right count here. So right count is basically number of right count you maintain. And see if whenever you see a character that is not R, so here it could be L, here it could be S, that such character, that basically means whatever the right count is, whatever the number of cars you were going that were going from right, they will all collide here. And then make that right count 0. So that would give me all of the cars that are colliding due to that are going right. Then in the second iteration you can go from n minus 1 to 0 and find the number of cars going left. So that is going backwards basically n minus 1 to 0, and then you can maintain your left count. And whenever you encounter a character that is not L, so that it could be S, it could be R, that means that those car would be collided here. This is one implementation, but there could be a simpler implementation. This is also O of n only. So this is also O of n, but the simpler implementation is, see, the total number of cars is n minus number of cars that don't collide. Okay, so this would be an answer, right? Total number of cars minus the number of cars that do not collide. How can you find this? See, the number of cars that do not collide, it could be three cases. It could be a static case, that the string says that the car has a state of s. If it has a state of s, yeah, if it has a state of s, then we never count it as collision, right? Like here the total number of cars is 1, 2, 3, 4, 5, 6. So 6 minus number of s characters in the string, because see, this for this s it is not moving. The cars can collide to it, but it won't collide to anything. So s 6 minus 1, right? The number second case for a character to or for a car to never collide is has a prefix L. So prefix L. What I mean here is, let's say the case is LLRR, which is the second case, I think so, or the second test case. See, for these left cars, they are moving left and with the same speed, so they will exit are basically are bound. So now it is said to be an infinite array. Let's see if they are moving L and there are no. This is like at the prefix, right? This is at the prefix. There is no other character before it, so it will move. It will continue moving infinitely and never collide, right? So prefix L. This is another case. The third case is just the opposite of this, which is suffix R, right? So similarly here also, these cars are at the suffix and moving right, so they will continue moving right and never collide. So what would our answer finally become? It would become n minus s minus prefix L minus suffix R. You can calculate s by just iterating over the string, uh, and count the number of s or the frequency of s. Prefix L, you can go to the like the prefix till the character is L, count till where you were able to go, and like here LLRR, LLRR, or if let's say it was like this. So you go over here. This is there's no other character than L. Then you go over here. There's no other character than L. There's another character, so you break here. And what would be a prefix L? 2. Similarly, you can go over suffix R. So here, no other character than R. That is fine. Here, there is another character, so you break here. And suffix R would become 1. So your final answer would be 1, 2, 3, 4, 5. 5 minus 2 minus 1. And here, there is no S. That is 2. And the two cars collide. These two cars are in it. Let's go over the implementation quickly. It's a pretty simple implementation. So all you need to do is basically in S I am storing the frequency of S in the in this direction array or direction string. In prefix L I am storing the number of L's in the prefix. In suffix R I am basically storing the number of suffix of this. I go over suffix of R basically. So I go over all the characters in the string. If it is S, I increment by S plus plus. And as I said, well, for calculating prefix L, if the character I'm going from 0 to n minus 1, if the character is L, I will add it to prefix LL. L else will break, because then the prefix is getting broken. There's another character. After this, prefix L should not be incremented. Okay. Similarly, I go from n minus 1 to 0. I increment my suffix R. If the characters are, else I just break. And finally, as I said, the final answer is n minus prefix L minus suffix R minus S, because these are the all the cars that do not actually collide. And this works. Let me just see. Yeah, this works. Thank you for watching. Bye bye.